Perseverance's sampling and catching system uses a hollow coring bit and a percussive drill at the end of its 7-foot long, 2-meter long robotic arm to extract samples. Telemetry from the rover indicates that during its first coring attempt, the drill and bit were engaged as planned, and post-coring the sample tube was processed as intended. Data sent to Earth by NASA's Perseverance rover after its first attempt to collect a rock sample on Mars and seal it in a sample tube indicates that no rock was collected during the initial sampling activity. The image taken by one of the hazard cameras aboard NASA's Perseverance rover on August 6, 2021 shows the hole drilled in what the rover's science team calls a paper rock in preparation for the mission's first attempt to collect a sample from Mars. Jessica Samuels, the surface mission manager for Perseverance at NASA's Jet Propulsion Laboratory in Southern California, said, "One of the steps that occurs after placing a probe into the collection tube is to measure the volume of the sample. The probe did not encounter the expected resistance that could be there if a sample were inside the tube." Jennifer Trosper, the project manager for Perseverance at JPL, said, "The initial thinking is that the empty tube is more likely a result of the rock target not reacting the way we expected during coring, and less likely a hardware issue with the sampling and coaching system." Let us consider now what may mean that the rock target not reacting the way we expected during coring. In my opinion, it was assumed that we have to do with regolith, the crater floor fracture trough, and the flow of zero. But consider for a moment that we have to do with exposed water, CO2, ice mixture with salt and sand, and the plain light rocks are not rocks actually, but an ice at the surface and not the flow of zero. What we can get then? Cones of gringed ice and sand dust around the hole and the remnants of vaporized sand inside the hollow coring bit, which are not solid hard rock anymore, but seem form dust which could escape throughout vaporize from the tool warmed during drilling. And why the rim of the hole did not melt? It may be because the ice has very high heat permeability and the heat is immediately dissipated in surrounding ice. Well, we need to try to drill in some loose rock stones protruding, lying loose above the plain floor of zero rather. These are remnants of crushed against this floor meteorites, and the floor could solidify back after melting during such collision to the plain light rock, eroded later into fractured rock. And now in Polish. Co może oznaczać, że obrana za cel skała nie reaguje podczas wiercenia tak, jak tego oczekiwaliśmy? Zakładano, że mamy do czynienia z regolitem tam w Crater Floor Fracture Trough na dnie zero. Ale zastanówmy się przez chwilę, czy przypadkiem nie mamy tu do czynienia z odsłoniętą mieszaniną lodu, woda, zestalony tlenek węgla z solą i piaskiem. A zwykłe, jasne skały nie są w istocie zwykłymi skałami, ale lodem na powierzchni, a nie na dnie jeziora. Co możemy wtedy uzyskać? Stożek ze zmielonego lodu i piasku wokół otworu i resztki odparowanej próbki wewnątrz pustego kawałka odwiertu, które nie są już stałymi twardymi skałami, ale po prostu tworzą pył, który mógłby wydostać się wylać, odparować z narzędzia ogrzewanego podczas wiercenia. Pył lodowy. Dlaczego krawędź otworu nie stopiła się? Czy nie dlatego, że lód ma bardzo wysoką przepuszczalność cieplną, a ciepło wiercenia jest natychmiast rozproszone w otaczającej olbrzymiej masie lodu? Dlaczego jeszcze raz krawędź otworu nie stopiła się? Ponieważ lód ma wysoką przepuszczalność cieplną, a ciepło jest natychmiast rozproszone w otaczającym lodzie. Cóż, powinniśmy raczej spróbować pobrać próbkę z niektórych luźnych kamieni skalnych wystających luźno leżących nad płaskim dnem, a raczej zamarzniętą powierzchnią jezera. To pozostałości skruszonych przy uderzeniu w tę powierzchnię kamiennych meteorytów, a sama powierzchnia może zestalać się po chwilowym nadtopieniu podczas takiego zdarzenia meteorytu z płaszczyzny jasnej skały w wyniku późniejszej erozji przeobrazzonej we fractured rock. I wracamy do komunikatu z NASA. Recently, the Perseverance Science team began using color images from the Ingenuity Mars helicopter to help scout for areas of potential scientific interest and to look for potential hazards. Ingenuity completed its 11th flight Wednesday, August 4th, traveling about 1,250 feet, 380 meters downrange of its current location so that it could provide the project aerial reconnaissance of the southern Saytah area. The rover's initial science foray, which spans hundreds of sols on Martian days, will be complete when Perseverance returns to its landing site. At that point, Perseverance will have traveled between 1.6 and 2.1 miles, between 2.5 and 5 kilometers, and may have filled up to 8 of its sample tubes. Next, Perseverance will travel north then west towards the location of its second science campaign, in the Rockettes Delta region. The delta is the fan-shaped remains of the confluence of an ancient river and a lake within Jezero crater. The region may be especially rich in carbonate minerals. On Earth, such minerals can preserve fossilized signs of ancient microscopic life and are associated with biological processes.